These are the formulas we're going to use in 6.1d. Previously, we discussed the difference between component form and linear combination form of a vector. We've also previously found a vector's magnitude, which is the length of the vector. You may notice a change in notation. I wrote both ways that the magnitude of a vector can be written. Our book uses a single set of long lines around the V, but other books use a double set. This is just good for you to file away. We're going to use this formula to find a direction angle, and if we know both the direction angle and the magnitude of a vector, you can use those two things to write a vector in component form. Let's look at a few examples. First, we're going to sketch the graph of the vector described. The direction angle here is 115 degrees, and the length of this vector is length 6. We want to write the vector in component form. Remember, component form just means how far you have to move right or left from the tail, comma, how much you have to move up or down to arrive at the head. We can use this formula to find the component form of the vector. We already know the magnitude and the direction angle. Substituting these values in, we get this. Next, we pick up our calculator and make sure we're in degree mode and enter each of these expressions. We find the vector in component form is negative 2.54, 5.44. This example, we start with the component form of the vector, and we want to determine the magnitude and direction. Making a sketch of vector 3, 2, I move right 3, up 2, and here is my sketch of vector 3, 2. To find the magnitude, I want to find the length of that purple vector. Here's the formula. Substituting the values for a and b and simplifying, we get the square root of 13. So the length of that vector is square root 13. Next, I want to find the direction angle. That's this angle right here. This is the formula we use to find the direction angle, where theta represents the direction angle. Substituting my values, I get this. To get theta alone, I need to take the inverse tangent of both sides. Making sure my calculator is in degree mode, when I take the inverse tangent of 2/3, I get 33.69 degrees. So the direction angle is 33.69 degrees. We're going to look at a second example of finding magnitude and direction. It's going to be much the same as the last example, but at the very end, we have to think about it a little bit more to figure out the direction angle. Sketching a graph of this vector, I move left 4, up 3, and draw my vector. To find the magnitude, the length of this vector, I use this formula, substitute in -4 and 3, simplify, I get the square root of 25, which is 5. The length of the vector is 5. Now I want to find the direction angle. Here's my formula, and I substituted my values. To get theta alone, I take the inverse tangent of both sides. If you remember, answers to inverse trig functions, if we use my silly trick, inverse trig functions are OEO or SAM-IAM functions. If you are tangent inverse, tan, A is in the middle, that is a SAM-IAM function. So when you use your calculator, you know the calculator is only going to give you an angle measure in quadrants 1 or 4. But clearly the angle to get over to this purple vector is going to be outside of quadrants 1 or 4. Let's go ahead and use the calculator in degree mode to find the inverse tangent of -3/4, and we get -36.87 degrees. Again, this is not surprising because inverse tangent has a range from -π/2 to π/2, or from -90 degrees to 90 degrees. This is why it's a good idea to always sketch your original vector. Looking at your sketch, you can determine if the angle measure is reasonable. When you're looking at a picture of the vector, you can clearly see that the angle measure is not -36.87. Let's go ahead and graph angle -36.87. Rotating clockwise 36.87 degrees, we would have this angle here. The period of tangent is 1 pi. Looking at the symmetry here, you can see to get to the angle measure we want, we could just add 180 degrees. We get 143.13 degrees. That is our direction angle. So if you are finding a direction angle and your vector is located in quadrants 2 or 3, you're going to need to look at the picture and use some symmetry to figure out what the angle measure is off of the x-axis.